Hey there. This is part 2 from the 10.5 applications of systems of equations. In the previous example, in the first video, I did a similar type of problem with investing money at different percentages. Well, now we have, for this problem, a mixture of 14% disinfectant solution. So when I go through this, you can just read it through first one time, but then when you're going through it, you might want to start underlining the pieces that are important. So you have a mixture of 14% disinfectant solution that's to be made from, we're trying to make a mixture of 14% disinfectant solution, and it's going to be made from combining some 12% solution and 20% solution. So you're going to mix those 12% and 20% together to get a 14% solution. How much of each type of mixture, the 12% and 20%, should be mixed to make 32 gallons. So when you think about this, so our question is how much of each type of solution should be mixed to make 32 gallons. Are you going to need more 12% or more 20% if you're going to try to make it combine to a 14% solution? And hopefully you're thinking more 12% because 14% is closer to 12% than 20%. Okay, so let's look at what we're trying to find here. How much of each type of solution should be mixed to make 32 gallons? So I'm going to let X be the amount of 12% solution. And so that means that the other, 88% is like water or something like that, something that is not a disinfectant. And then Y can be the amount of the 20% solution. And you can use whichever variables you want. I'm just being boring and using X and Y. Okay, and now our goal is to make a solution that's 32 gallons at 14%. So first of all, we want 32 gallons. So the amount of solution that we pour in that's 12% plus the amount that we pour in that's 20% has to total that 32. That's one of our equations. X, the amount of the 12% solution, plus Y, the amount of 20% solution, has to total 32 gallons. Then the other one is going to have to do with making the percentage equal to 14%. That 32 gallons has to be 14% solution, disinfectant solution. So remember, if you're converting a percent into a decimal, you move the decimal over 2 places. So 12% is going to be 0.12. You can write 0.12. You don't need the 0, but it can sometimes be helpful so that you don't miss the decimal. It's hard to see that sometimes. And then 20% as a decimal is 0.2. And then we're going to also want to convert the 14% to 0.14. All right, so this next solution, we're going to add X gallons of the 12%, and the amount of solution in that is 12% times X, however much we add. 12% of it is, of the X gallons, is going to be disinfectant, plus 20% of our solution Y. We're going to add those two together, and we want it to combine to be a 14% solution of the whole 32 gallons. So what you're going to do over here is you're going to take 14% times the amount of gallons, the number of gallons that we want in total. So if you just look at like what is 14.14 times 32, that is 4.48. That means like if you have 32 gallons of this solution, 4.48 gallons have to be the disinfectant. The rest is whatever, water or whatever they put in a disinfectant. And so for this problem, then this was 4.48. So I'm going to just write that out. So I have 0.12x plus 0.2y equals 4.48. And then you can work this out with decimals, it's perfectly fine, but it can oftentimes be a heck of a lot easier if you get rid of the decimals. And to do that, I have 2 decimal places in some of the numbers, so I'm going to multiply by 100. If I multiply by 100, this just moves the decimal over 2 places. So it'll be 12x. This will be 2. If I move it over 1, I still need to move it over another one, so I need to add a 0. So this is 20y. And then 4.48, moving that decimal over, that's 448. So that's the equation we're going to combine. So this is my equation 2, my equation 1. I'm going to rewrite it down here. I have x plus y equals 32, and you can solve that whichever way you want, with a substitution or elimination. You choose. How about I'll do this one right now. I have 12x plus 20y. I'm going to multiply this equation by negative 12. And then I have, so that'll be negative 12x minus 12y, and 32 times negative 12 is negative 384. I'm going to add that to my equation that I wrote here. So 12x plus 20y equals 448. Add down. The x's will be eliminated. And you have 0x, and then this is going to be 8y. And you have 64 over here, a negative 384 plus 448. Divide by 8, and I get y is 8 gallons. So I'm going to add 8 gallons of the 20% solution, and the rest is going to be the 12% solution. So if I do 32 minus 8, I'm going to get 24 gallons of 12% solution, disinfectant solution. And that, at the beginning I said, well, which one would you add more of? And it would be the 12%, because 14% is closer to 12%. So we have a lot more, 3 times more gallons of the 12% solution here. Okay, this last problem is a little bit different. I want you to go ahead, pause the video, and write it down. So if it takes you 3 hours to travel 33 miles downstream, so the current's going with you and pushing you faster, and then when you go back upstream, you're traveling, it takes you 4 hours, so it takes you even longer, but you're going even fewer miles, only 28 miles upstream. What is the speed of the boat in still water? What is the speed of the speed of the current? Those are your questions, so what does that mean? That means that we need to let x equal the speed of the boat. That's what we are trying to find, so it's the unknown, so we want that to be our variable. In still water, I'm not going to write all that out, but that's just the speed of the boat without the current involved. And then y is the speed of the current. Okay, so there's a couple different ways. That's supposed to be a current here. There's a couple different ways you can do this problem. I think one of the easiest ways is, let's first of all figure out our rate going upstream. So we need to know this equation. Your distance that you travel is equal to your rate times your time. And we're going 33 miles in 3 hours. So if I go a distance of 33, my rate is what I don't know yet, and then in 3 hours, that means if I divide by 3, and I divide by 3, and this was in, 33 was in miles, and 3 was in hours, so my rate is 33 divided by 3, which is 11, and it was miles per hour, because 33 is in miles, and we divided by 3 hours, so it's miles per hour. And then do the same thing for going downstream. We're going a distance of 28 miles in 4 hours. So dividing by 4, you get your rate going upstream is 7 miles per hour. Okay, so then if we're going if x is the speed of the boat and y is the speed of the current and we're going downstream, one of the equations for going downstream is we know that the rate that the boat is going, the speed that the boat is going, plus the speed of the current is going to tell us how fast we're traveling downstream. And we just found out that that was 11 miles per hour when we went downstream. And then to come back upstream, we're going 7 miles per hour. So the speed of the boat is we're fighting the current this time. So the current is actually going to be pushing us in the opposite direction. So I'm going to take the speed of the boat minus the speed of the current because it's going to offset, and that should equal 7. And now we can take this, it's set up perfectly for solving by elimination. It's the y's are already opposite, so you can just add straight down. I got 2x, positive y minus y is 0, 2x equals 18, and divide by 2, and you get x is 9 miles per hour. And if you've defined your variables, you might go back and like, what's x? X is the speed of the boat. So this boat is traveling at 9 miles per hour. And then we know we can plug x equals 9 in for either one of these equations. But if x is 9, then I have 9 plus the speed of the current equals 11. Subtract 9, and we get y equals 2 miles per hour. So the current is pushing us downstream faster by 2 miles per hour, and then upstream we're losing 2 miles per hour. It's fighting against the speed of the boat. Okay, so that is majority of the types of problems you're going to get for 10.5, and just bring your questions Monday.